Okay, so far you've been given a brief introduction into what object-oriented programming is, and hopefully you have a good idea of the difference between, what a class is and what instances of those classes are objects. So it's kind of that basic distinction of classes being the blueprint, and then when you actually go to implement or to create that blueprint, you're creating objects or instances. The blueprint for a house and all the different houses that are made that might have different colors or different shades or different whatever there might be based on that blueprint. Today we're going to drill down a little bit further into some of those weird nuances that kind of trick people up a little bit when they start to learn about object-oriented programming. And the first of those is about the difference between a variable or a method that's been created that's static and non-static. So when you think of static, already you can think of something that's not changing. It's kind of rigid. And non-static or instance methods or instance variables are things that are going to change depending on the object, depending on the creation of that blueprint, the individual things. And I'll give you a lot of examples to help illustrate that concept as we go through. So when we talk about global variables, and you might have heard that term before. These things of global variables are pieces of data that belong to that class. And the idea of static is something that sticks around no matter how many of those particular classes are instantiated. That same variable, that same method is going to be static throughout all of them. What that means is that it can't change depending on the particular house or the particular dog or the particular whatever is created. Everything that it does has to stay the same between all of those. So let me kind of explain it another way. Sometimes when I create a house, I might want that house to have different color of brick. If I want each house to potentially have a different color of brick, I need to make that an instance variable, because that variable is going to have some reserved space in each and every single house that's created. Every house is going to have its own type of brick reserved just for it, and it's not connected to any of the other houses that might be built. If there's something that might stay the same across all of the houses, like for example a model name, that can be static, because it doesn't matter how many instances of this I create, they're all going to have the same model name, right? They might all have the same square footage. That might not change. I have a blueprint, the square footage stays the same. That might be a number that is not going to change for all of the houses that are built using this particular blueprint. And in programming, by default, when you create a variable in a class, it's considered to be an instance variable. It's considered to be something that is going to be unique to every single object that's created for it. If you don't want that behavior, if you want that one piece of memory to be shared amongst all of the different instances of it, then you have to declare it with the qualifier, with the word static inside there. And that's going to have very different behaviors depending on whether something is static or not. And one of the best ways is to actually see that, which I'll demo for you in just a second. So for now, let me just show you some examples of static versus instance in Java itself that already exists, that you've probably already used in your beginning programming. So look at the ones on the left for a second and look at the ones on the right. One set of methods is static and one set are instance. Can you sort of tell the difference between the two? There's something different in the way that they're called and the way that they're used. The ones on the left, they're static. And the way that we use them is by calling the name of the class. So this math here capital M math is the name of a class, and the way I access the method from that class is by using the class name, math.power. And so you'll notice that I can pass information into it, but I don't need to rely on the instance. I don't need to rely on actually creating an example or an instance of a math class. I just go directly to that math class and I can access the functions. And that's because in order to calculate a power, I'm giving it everything I need for it to know inside those parameters inside here. The ones on the right, they don't make any sense except in the context of what this C is. Somewhere a variable called C or console or something like that was created. And once it's created, I can print line. But if I'm going to print a line, I have to print it to something. Something must have been created. An instance must be created somewhere. And it's that instance that I'm going to print to. If I'm going to set the color of something, I'm going to set the color not to the idea of a console in general, but to a specific console. And I could set a different console to have a different color. So static here on the left, and instance here on the right. So just to summarize a little bit of what I've been talking about, here on the left we've got this idea of static methods. Okay, no matter how many instances of the class, no matter how many houses you build, a static is going to be the same. It's shared amongst all of those. Instance is going to be different depending on each individual instance. And so if I, the example down here, if I have a robot, this class, this robot is just the blueprint. But every time I create that robot, I can give it a unique name. And one robot might be called Hal, and my next robot might have a unique name called 626. And when I go to move my robot, I have to use a particular robot that I have created. So this last line of code here, it would fail in this particular example because I haven't created a robot, an instance of a robot with that name. If I wanted to move a specific robot forward, I could give it r2.moveForward, or I could say d2.moveForward. I can't say robot move forward because that doesn't make sense. I need a specific robot to tell it, you're going to move forward, and this is how many spaces you're going to move forward. And that's an instance. It's attached to the individual robots that are being created. Once you start to get into object-oriented programming, one of the things you realize really quickly is that most of what you want to do is creating instance variables and instance methods. You're actually not going to use static very often. In fact, very often in most of your programs, you're only going to have one thing that's static, and that's going to be your main method. And those of you who are astute are probably starting to realize why main has to be static. And that's because main is just the starting point of your program. It doesn't matter what class it's in. It's not going to be different depending on how many different instances you create. That is where your program starts. And your program branches out from there. But it's always going to start in that one spot. And so that's why static is main is static. Okay, so if I was creating a class, the minute that I put variables inside the class, if I don't use that keyword static, those variables are now instance variables. They're going to be different, a unique set of memory every time I create it. And so this class hello objects has two different variables, one called var and one called var2. And I can have a method here, and again, if I don't use the keyword static, that means that this method is going to be part of each individual instance. And if this is going to be part of each individual instance, then that means that I can access these other pieces of information, because change int is going to behave differently depending on the values each of these variables is going to have. If I were to have created this method as static, I would start to get errors. And I'll show you that in NetBeans in just a second. So then the last thing is, of course, the static main method over here, and you'll see that I'm creating two separate and distinct instances of hello objects. On one of them, I'm calling this method to change the integer. And then down here, I can print out the information. And of course, one will have changed and one will not have changed because they're completely different instances. So I've jumped really quickly into NetBeans. And so here's where we're writing our Java code here. You'll notice I've created a class just like you've done many times in the past. I don't have a main method yet. I'll add one in just a second. So I'm trying to create a robot, and I'm thinking a robot's got to have some useful stuff with it. And so I'm going to create a variable, maybe to represent its X location. Okay, and I'll just give this a starting value. I don't really need to. Maybe I'll create another variable to represent its Y location. And then now let's just say we'll make this one static. I'm going to create a static string to represent its name. Now what that means is that whenever I create a robot, it is going to have a unique X, a unique Y location, but it's not going to have a unique name. That name is static. It's going to be shared amongst all of the robots. So to save a bit of time, I skipped ahead and added in a main method. And in this main method, I have gone and I have now created a new robot because I've created a new data type, a new class. I can now go ahead and create a new robot. Now, all of these methods are available for me to, all of these variables are available for me to do stuff with. So I can say, r.x equals 5, and I can change the x location for that. I can also say r.name equals Bob, and I will have changed the name of that robot. I can go on and I can create another robot. Let's call this D. And I could go ahead and I could give D its own information. Let's do the Y this time. And I can go ahead and change the name, and I want the name to be Doug. Beautiful. Now right away you're thinking, okay, but name is static, and RD said that behaves differently than this, and it does. And I'm going to pause again, and I'm going to write some print line code, and you're going to see how that behavior is different. So I've gone ahead and done that. I added in some print line information. You'll see that I'm going to print the X value for robot R, as well as the name for robot R. And then I'm going to go ahead and print the X value for robot D, and then the name for robot D. So we're going to go ahead and run that. And these results are going to tell us a lot about what it means to be static. And so you can see that when I went ahead and changed the X value of robot R to 5, it changed that X value, but it didn't change the X value for the other robot because it's an instance variable. It belongs. It's a distinct set of data for each one. But now look what's happened is I set the robot R's name to be Bob, and then I went ahead and changed, oh, well, now that's a little silly. I needed to make this D. Let's do that really quickly. Okay, and then I went ahead and I changed robot D's name to be Doug. And what's happened is that when I go and print out R's name, it says Doug. And when I've gone ahead and printed out D's name, it said Doug. And that's because that same piece of data, that same bit of memory is being shared. It's being shared by R, it's being shared by D, it's being shared by every single robot I ever make. And that's because static means that it is not being created for each instance. It's sharing one piece of information. One variable is being shared amongst all of those instances. And that is a very key difference. I could not have each robot having a unique name if I go ahead and make this static. And when you think about it, most of the things that you want for a robot are not going to be static. And that's why most of the variables you're going to create from now on are not going to have that piece in there. The other thing that we talked about was methods. Methods can also be it can be static or non-static. So I can say public static int, and let's say I want to change my x value, and I want to change it by adding something to it. Okay, so here I've created a method. It is going to change the x value. I'm going to pass in a number, and it's going to change the x value based into it. But notice I've made it static. And remember, again, static says that it's going to look the same depending on all the instances, which means that I can't make a change to x. And I'm going to try, and you'll see what happens. But I can't make a change to x because x doesn't exist in the blueprint as a value. It's something that is going to be different depending on each instance. And so if I want access to these variables that are going to change for each instance, when I create a method, I also need to make sure that it's not static. Because the minute that I try to do, I should give this a better name than that. The minute that I try to do x equals x plus a, it is not going to like it. And it's going to give you some message, and remember this message because you're going to see it at some point. It says non-static variable x cannot be referenced from a static context. That bit that tongue twister there is really just saying that you are in a static method, which is something that cannot access specific pieces of data that change from instance to instance. You can't do it. If you're in a static context, you can't access. It's just like from main. I cannot from main decide that I want to go ahead and access the X of the robot. It doesn't make sense. You have to have a particular instance of it. And so what I would do is I would remove this static context from it. And now I can go ahead and call it, and it will change the X from it. And because I've created this method here, and because it is part of the class, I could, if I wanted down here, now say r.changex, change x, and I could give it a number, and it would go ahead and actually make the change that I wanted to that particular robot. You can have static methods, but static methods are things and you should sometimes. But the only time you're going to want a static method is when it's doing something that doesn't rely on any of the data that's specific to the instances of that class. That's why math.pow works great as a static, because you give it the two numbers, it manipulates those two numbers, and then it's done. It spits out the answer. It doesn't need any other information. It's self-contained within itself. So hopefully that's some good examples of what static is and what you can do. There's an even greater little neat advantage that programming in this way gives us, and I'll explain that in just a second. So one of the first things that I tell students when they're learning methods is that a method follows a simple rule, and that is it can do whatever work that you want it to do, but it can only return one thing, right? You can return an integer, you can return a string, but a method is always restricted to return one thing. And when I tell my students this, I tell them, yeah, I'm calling it a rule, but as you're going to see when we get to intermediate programming, there's actually a few ways to break that rule. And now that you've learned about static and instance, this is the first way that we can break that rule. And the way that you can break it is that you know that we now have this idea of instance variables. And these variables belong in a class, and they're also variables that are accessible to any non-static method that is inside that class. That means that a method has access to those instance variables, it can change those instance variables, and so now we can have a method that could do a whole bunch of work. It might not return anything, but it could go ahead and affect as many of those instance variables as it wants to. And that's because everything inside an object has access to everything else inside the object, right? If it's there and it's part of the object and it's a variable, it has access to be able to change that. So let me just jump back into NetBeans really quickly. So here you can see all that hard work we were doing before. And I was starting to create that change method, but perhaps I want to have a method that's a little more subtle. So public int, let's just have this robot move, and I want to give it a new x, and I want to give it a new y. So now that I'm in here, this is not static, so I'm going to be able to access these. I can very easily say x equals ax, and I can also say y equals ay. And what I've done now is I've been able to make two substantial changes to things in this class within this method. And so I'm now able to make two changes. I don't have to return anything. In fact, really, I should just get rid of this. I don't want to return anything. I'm going to make some changes to these things and then I'm done. And now that's a great example of how I might do that. And then down here, I can now have access to this new one, and I can say move, and I want to move by that much, or I want to move to that location. So I'm now about done with the explanation of static and non-static, and for some of you I might have belabored the point a little bit, but it is one of those tricky concepts to grasp, and I want you to actually give this a shot yourself. And so in a moment I'm going to ask you to create a square class. Try it on your own. If you have troubles or if you have questions, you can always throw it into the comments or send me an email or a chat. And when you are trying to create, this will be your first real kind of class that you're going to create. And in general, when you're trying to create a program in an object-oriented programming style, you start thinking about the objects. So I want to create this thing called a square. And the first thing you ask yourself is, what sorts of information do I need to know in order to make a square? Or what sorts of information does each square need to have? And so that information might be a little bit different depending on how you want to implement it. So for example, it could be that I think a square should have 2 points. So an x and a y and an x and a y. And as long as I have those 2 points, then I can define my square and that's it. Somebody else might say, I only need 1 point and I need a length. And as long as I have 1 point and a length, then I have all the information that I need for the square. A third implementation might be, I want all 4 points for the square, and with all those 4 points, then I've captured all of the information that I need about the square. Still other implementations might be looking at a completely different aspect of what it means to be a square. It might look at the color of the square, the outline, the fill color, right? So you need to think about what information you're trying to capture about that square. Then, once you think about what you need to actually represent the square, you think about what sorts of operations you might want to do on the square. What's important? You might want to be able to set the x position or set the y position. You might want to calculate a simple formula like area of a square, of that particular square. You might want to be able to shift the square around. You might want to be able to change the color. You need to think about, for your implementation, what's important in order to represent the square. But all of those things that we've been talking so far are non-static. There might also be some static methods. There might be things about a square that are not going to change and that don't depend on it. Maybe you want to include a definition, so that when someone calls the method definition, it gives a generic definition of what a square is. That would be something that's static. You don't necessarily want it to change from square to square. And so what I want you to do as a bit of an exercise is I want you to think about a square. There's no right or wrong way to create it. You think about what's important to define your square. And I want you to create the structure for that square. Don't worry about implementing all the details and calculations. but try to implement the structure for it. Create a couple methods for it, create some instance variables, and then let me know how it goes. This is kind of be your first real class that you've created using this new style of programming. All right, give it a shot. Let me know how it goes.